Welcome to episode 53 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data and AI with you.
And I'm Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Farming smarter with sensors and models.
That's right. Today we're diving into AI in agriculture, where new tech is transforming the way we grow food, manage land, and predict harvests.
To begin, let's talk about precision farming. It's a term you'll hear a lot in this space. Basically, it means using detailed data to manage farming activities more exactly than ever before. Think of it as tailoring care for each plant and every square meter of a field rather than treating everything the same.
Exactly, Jonas. Precision farming is all about efficiency and sustainability. For example, instead of uniformly watering an entire field, sensors detect exactly which areas need water, and only those get irrigated. This saves resources and boosts crop yields.
The backbone of precision farming is data collected from various sensors. These can be in the soil, on drones flying overhead, or even embedded in farming equipment. The data collected includes soil moisture, temperature, nutrient levels, and even crop health indicators like leaf color.
I've seen this firsthand with a client in the Midwest who installed soil sensors across their 2,000-acre farm. They combined that data with weather forecasts and satellite images to decide precisely when to fertilize and irrigate. Their crop yield increased by 15% while cutting water use by 20%. That's a game changer in a sector often subject to unpredictable weather and rising costs.
It highlights how AI models use this sensor data. The process usually involves collecting large volumes of data, then applying machine learning algorithms to identify patterns or make predictions, such as when crops will reach maturity or when pests might strike.
That crop prediction part is fascinating. One company I worked with developed an AI system that predicts wheat harvest timing with surprising accuracy. They integrated past yield data, weather patterns, and satellite images. For farmers, that means better labor planning, optimized use of machinery, and minimized spoilage.
Historically, agriculture was heavily dependent on intuition and experience passed down through generations. What AI brings is a quantifiable, repeatable approach, transforming farming from an art into more of a science backed by data.
Although, I'd say it's not just replacing intuition, but enhancing it. Farmers still know their land best, but now they have data-driven insights to make smarter decisions. It's a collaboration between human expertise and AI.
Well said. A related concept here is the Internet of Things, or IoT. In agriculture, IoT means connecting all these devices, sensors, drones, tractors, to a network so they can collect and share data continuously.
Another great example. One large vineyard in California uses IoT sensors embedded in soil and on grapevines. These sensors monitor moisture, temperature, and sunlight in real time, feeding data into AI models that help farmers decide the best times for irrigation and harvesting. The vineyard increased their grape quality and reduced water waste significantly.
When we talk about models here, it's often about predictive analytics. The AI learns from past data and current conditions to forecast future outcomes, be it crop yield, pest infestations, or disease outbreaks.
Speaking of disease outbreaks, there's a case in India where satellite images combined with AI helped predict locust swarms. Early warnings allowed farmers to protect their crops with targeted treatments before massive damage happened.
That's an excellent illustration of AI's preventive power. Predictive models help mitigate risks rather than just react to problems when they occur.
Exactly. Though I want to mention some challenges too. Despite the promise, adopting AI in agriculture isn't as simple as flipping a switch. Many farms, especially smaller ones, struggle with the upfront costs of sensors and connectivity. Plus, the data itself can be messy. Weather changes, sensor malfunctions, or local soil differences add complexity.
Indeed, data quality and accessibility are fundamental. AI's effectiveness depends heavily on the volume and reliability of inputs. Without diverse, accurate inputs, models might produce flawed recommendations.
This is where partnerships and government support can make a big difference. Subsidies to help farmers buy IoT equipment or data sharing platforms that anonymize and aggregate farm data help spread the benefits of AI more broadly.
Another important aspect is dynamic adaptation. Agricultural environments change quickly, seasonally and yearly. Models need to continuously learn and update to stay relevant, a process sometimes called online learning or adaptive AI.
On the practical side, this also means farmers and consultants must be trained to understand and trust AI recommendations, which brings a cultural shift. Vendors who offer easy-to-use dashboards and clear explainability help adoption.
Let's not forget sustainability, the big picture. AI can reduce overuse of fertilizers and pesticides, lowering environmental impact. It supports biodiversity by promoting healthier soils and reducing runoff into rivers.
And from a business perspective, agriculture is often a low-margin industry. AI-driven efficiency means better profitability even in tough market conditions. Plus, consumers increasingly demand sustainably grown food, so AI can help farms meet that expectation.
To summarize, AI in agriculture revolves around precision farming and crop prediction, powered by sensor data, machine learning algorithms, and IoT connectivity. The goal is smarter, more sustainable farming.
And as we've discussed, the real-world impact includes higher yields, resource savings, early problem detection, and ultimately more resilient farms.
Key takeaway? AI is not just a futuristic idea for farming. It's happening now, turning traditional methods into data-driven practices that improve outcomes and sustainability.
And for business leaders, the lesson is clear. Investing in AI and data infrastructure in agriculture can bring measurable ROI and help meet growing food demands responsibly.
Next episode, we'll explore AI in government, how data-driven decision-making shapes public services, policy, and citizen engagement.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We'd love to hear your thoughts or questions on AI in agriculture or any other topic. Who knows, your question might inspire a future episode. Until tomorrow, stay curious, stay data-driven.